Dear students, good evening and a warm welcome to CSAT Made 2025 series, where we discuss the most exam specific questions and concepts for the CSAT paper of 25 year. I am Sachin Gopanal, and for those who are watching the video for the first time, I will tell you what this series is all about. In this series, in this lesson series, we take a PYQ, we reverse engineer it, then decode the concept behind it, and then we present it in the form of questions. And today's topic would be HCF. What is HCF and how do we find HCF? We shall look at it from the starting videos. So once again, welcome. Let's first see what a HCF is. What an HCF is. Okay, this is how we define an HCF. The highest common factor of two or more numbers is that number which divides the given numbers, leaving nil or zero remainder. What does this mean? It means that if there are two numbers, if there are any given two numbers or three numbers, the highest number which will divide all the given numbers and leaves a zero remainder, that means it divides them completely without leaving any remainder, that would be called as HCF. For example, the HCF of 6 and 9, that would be 3. The HCF of 40 and 50, that would be 10. Similarly, the HCF of 81 and 90, that would be 9. This way, the HCF is the biggest number that will divide the given numbers without leaving any remainder. Okay. We understood what HCF is. How do we find HCF of given number? How do we find it? We shall learn that from the first question. And as always, we will begin with basic questions and gradually rise up to exam level questions. So look at the first question. What is the HCF of 126 and 189? What is the HCF of 126 and 189? And how do we do that? I will show you the procedure of finding HCF, and this procedure, it remains the same for any number of numbers. Okay, 126 and 189. Then we draw this structure for facilitating division. Okay, then we divide both the numbers from any number that divides both of them. For example, does 2 divide? We will start with the smallest number, but however 1 is not considered here. Okay, does 2 divide both of them? 2 divides 126, it is an even number. However, 2 does not divide 189 because it is an odd number. Does 3 divide both of them? Yes, because the sum of digits is 9 and the sum of digits is 18, so it is divisible by 3. 3 divides 126 as 3 4s are 12 and 3 2s are 6. Then 3 6s are 18 and 3 3s are 9. Okay. Then what do? We repeat the same thing. For these two numbers also. What we did for 126 and 189, we will repeat the same for 42 and 63. Does the 2 divide them? No. Does the 3 divide them? Yes, because the sum of digits is 6 and the sum of digits is 9. So both are divisible by 3. 3 1s are 3 and 3 4s are 12. 3 2s are 1 and 3 1 is 3. Okay. And we will repeat the same process till we get two numbers which do not have any common factor. Okay, which do not have any common divisor. And how do we find the HCF of 14 and 21? By looking at them, we know that both are divisible by 7, right? This is 7 into 2, this is 7 into 3. Now we arrived at two numbers which do not have any common divisor or any common factor other than 1. 2 and 3, they do not have any common factor other than 1. So we stop the process here. Then we will multiply the numbers on we will multiply all the factors that we used. We will multiply all the divisors that we made use of. So what is it? It is 3 into 3 into 7. That would be 9 into 7 and that would be 63. And 63 is your HCF. This is how we solve for HCF or any given number of numbers. It might be 2 numbers, 3 numbers, 4 numbers, however many numbers be given, the procedure remains same. And in this case, the What the HCF is 63. So what is our answer? Our answer is 63, option A. Okay. Now we will go to another basic question where we will learn another basic concept. If the HCF of two natural numbers A and B is 4, then what is the remainder when 4 divides A plus 3 and B plus 3 each? What are they telling us? They have already given HCF readily to us. They are telling us that there are two natural numbers A and B and their HCF happens to be 4. However, they want to divide A plus 3 and B plus 3, and what will be the remainder in each case? If 4 were dividing A and B, then the remainder would have been 0 because it is HCF. However, it is dividing A plus 3 and B plus 3. So, the concept behind this question is this: whenever the HCF of two natural numbers A and B divides A plus x and B plus x, provided x is less than HCF. Yes, here it is, the value of x is 3 and it happens to be less than HCF. Provided that x is less than HCF, the remainders in each case will be x. Here the concept says, the concept defines only two numbers. However, this applies for any number of numbers, 3 numbers, 4 numbers, the same concept applies. Okay. So by looking at this, we know that the remainder would be x, and what is x in this case? It is 3. So your answer will be option B, 3. Okay. Now we will go to another question where we will learn another concept. What is the greatest number that leaves a remainder of 2 when it divides 230 and 284? Okay, this is not same as previous one. There they had given us the HCF of two numbers and they had asked us to find the remainder when the two numbers were extended or increased by 3 numbers. However, here what are they asking us? They are asking what is the greatest number that leaves a remainder of 2 when it divides 230 and 284. So the concept here is that there is some number which when it divides 230 and 284, it leaves a remainder of 2, and they are asking us what is the greatest such number. There might be many such numbers. They are asking us what is the greatest such number. Okay, so the concept here is that greatest number, it must divide 228 and 282, right? Because if it divides 228 and 282 without any remainder, then when those numbers are increased by 2, that is 230 and 284, then the remainder 2 remains. Okay, read the concept here. The concept might look easier now. The greatest number that divides two natural numbers P and Q and leaves a remainder of x in each case will be the HCF of P minus x and Q minus x. If the HCF of P minus x and Q minus x is some number, let's take it as n. So n will be dividing P minus x and Q minus x without any remainder, right? So when you present it with P and Q, then it will leave a remainder of x. Okay, take down this rule, then read it once or thrice and it will make sense to you. So going by this rule, what will our answer be? Our answer will be the greatest number that divides two numbers P and Q and leaves a remainder of x in each case is the HCF of P minus x and Q minus x. In this case, P and Q are 230 and 284 and x is 2. So we need to take the HCF of 230 minus 2 and 284 minus 2. That would be 228 and 282. So we just need to take the HCF of the 2. How do we do that? Our process remains the same. We will divide by any common number. So both of them are even numbers. So we will divide them by 2. This would be 114 and this would be 141. And both of them, thus their sum of digits happens to be 6. So they must be divisible by 3. 3 3s are 9. 3 8s are 24. 3 4s are 12. 3 7s are 21. Okay. Now I think 38 and 47, they do not have any common factor. So now we stop our process and we multiply the divisors or the factors that we made use of. So what will the What are the factors here? They are 2 and 3, so we'll multiply them. 2 into 3, that is 6. So the HCF of 228 and 282 is 6. So 6 will be dividing 228 and 282 without any remainder. However, when you increase them by 2, that is when you change 228 to 230 or 282 to 284, then in both the cases it will leave a remainder of 2 as the question asks. So what will your answer be? Our answer will be option D, 6. Okay. I think after solving the question, you understood the concept better. Okay. Now let's go to the next question. The question says, how many natural numbers leave a remainder of 1 each when they divide 157 or 205? This question is different from the previous question. What was the previous question asking us? It was asking us what is the greatest number that leaves a remainder of 2 when it divides 230 and 284. However, here they are asking us how many numbers are there which will divide 157 and 205, and in both the cases they will leave a remainder of 1. The concept behind this question is this: the number of numbers that divide two natural numbers p and q and leave a remainder of x in each case will be the number of factors of HCF of p minus x and q minus x, excluding the factors that are less than or equal to x. Okay, this looks a bit confusing. However, after solving the problem, you will understand it better. So first, what shall we do? We shall find HCF of p minus x and q minus x. In this case, p is 157 and q is 205 and x is 1. So we will take the HCF of 157 minus 1 and 205 minus 1. What will they be? That would be 156 and 204, right? Yes, 156 and 204. And we will take the HCF. How do we do that? Both of them are even numbers, so we will divide them by 2. This would be 78 and this would be 102. Once again we came across even numbers, so we will again divide them by 2. This would be 39 and this would be 51. Both of them, they are divisible by 3 because 9 plus 3 is 12, divisible by 3. 5 plus 1 is 6. So their sum of digits happens to be divisible by 3. So divisible by 3. So the numbers are divisible by 3. 3 into 3 ones are 3 threes are, and 3 ones are 3 sevens are. So now we cannot divide them any further. Both the numbers, there is no common factor for them. So what will we do? We will multiply the factors that we made use of. That would be, we will multiply them. This would be 2 into 2 into 3, right? 2 into 2 into 3. That would be 4 into 3. So we found the HCF to be 12. HCF of 156 and 204. But we are not done yet. The concept says the number of numbers that divide two natural numbers p and q and leave a remainder of x in each case will be the number of factors of HCF. Number of factors of the HCF. How many factors does 12 have? We will list them. Starting from 1 and going up to 12. So 12 is divisible by 1, right? 1 into 12 is 12. Then 12 is divisible by 2. 2 into 6 is 12. Then it is divisible by 3. 3 into 4 is 12. Then it is also divisible by 4 because 4 into 3. Then it is also divisible by 6. 6 into 2. And ultimately it is divisible by itself. Yes. So there are 6 numbers that are factors of 12. So is our answer 6? No, because there is, read the clause here, the number of factors of HCF excluding the factors that are less than or equal to x. In this case, what is x? In this case, x happens to be 1. So do we have any factors which is less than or equal to 1? Yes, we have 1. 1 is equal to 1. So we will count only the rest of them. How many factors does this HCF have? 5. 5. So our answer will be option C, 5. 5 is our answer. Now let's see what the question actually meant. We will understand the concept better now. If you divide these numbers 157 and 205 by 2, yes, the remainder will be 1, right? Because 2 will be dividing 156 and 204 even numbers. So 157 and so when you divide 157 and 205 by 2, you will have a remainder of 1. If you divide 157 and 205 by 3, again the remainder will be 1, because 3 will be dividing 156 and 204 without any remainder. So when you increase the numbers by 1, the remainder will be 1. The same applies for all of them. All these numbers, they will be dividing 156 and 204 without any remainder, because their multiple 12 is itself 12 itself is dividing 156 and 204. So all these numbers, they will also be dividing 156 and 204. So when you increase those numbers 156 and 204 by 1 each, so then they will all leave a remainder of 1. Okay, this is not a very complicated concept. If you are confused, just rewatch the video and you will be able to understand it thoroughly. Okay, now let's go to the next question. Consider the following statements. If the HCF of two natural numbers a and b is 4, then the remainder when 4 divides a minus 1 and b minus 1 is 3. This looks to be a new concept, right? However, we can verify it easily. We shall understand the statement first. If the HCF of two natural numbers a and b is 4, then the remainder when 4 divides a minus 1 and b minus 1 is 3. Okay. So what are they telling us? They are telling us that if there are any two numbers whose HCF happens to be 4, and if 4 divides a minus 1 and b minus 1, if there are two natural numbers a and b whose HCF is 4 and 4 happens to be dividing a minus 1 and b minus 1, the remainder would be 3. We shall assume a and b's value and just check the statement if it is true or wrong. First we shall take which numbers? 8 and 12. Yes, their HCF would be 4, right? So we will divide a minus 1 and b minus 1. That would be 7 and 11. A minus 1 and b minus 1. Which number will be divided from? We will divide them by 4. If 7 is divided by 4, then the remainder would be 3, right? 4 ones are 4 and the remainder 3 remains. In this case, 4 twos are 8, then the remainder would be 3. Okay, it holds. We shall try some other set of numbers. 16 and 20. For 16 and 20, the HCF is 4 again. So we will divide 15 and 19, that is a minus 1 and b minus 1 by 4. If you divide 15 by 4, the remainder would be 3, because 4 threes are 12, so 3 remainder remains. In this case, if you divide by 4, again the remainder would be 3, because 4 fours are 16, the remainder would be 3. So in all of the cases, the remainder is happening to be 3. So we will declare that statement 1 is true. Okay, statement 1 is true. Now we will check statement 2. The number of natural numbers that leave a remainder of 2 each when they divide 140 and 176 is 3. Okay. Now we learnt how to solve this statement in the previous problem. How do we solve it? In such case, we will take the HCF of 140 minus 2 and 176 minus 2, and the HCF, after getting the HCF, we will see how many factors it has and how many factors are not less than or equal to the remainder. That many numbers will be there which will divide 140 and 176 and leave a remainder of 2. Okay, it might sound a bit confusing, however when we solve them you will understand it better. 140 and 176, we need to take HCF of what? 140 minus 2 and 176 minus 2, that would be 138 and 174. Okay, both are even numbers, so we will divide them by 2. If we divide them by 2, this would be 2 6s are 12 and 2 9s are 18. This would be 2 8s are 16, then 2 7s are 14. Okay, and both happen to be divisible by 6, because 6 plus 9 is 15, divisible by 3. 8 plus 7 is 15, that is also divisible by 3. 3 2s are 6 and 3 3s are 9. 3 2s are 6 and 3 9s are 27. Now 23 and 29, they do not have any common factor. So what will our HCF be? Our HCF will be 2 into 3, that is 6. Now 6 is not our answer. We need to see how many factors 6 has. 6 has these many factors, right? 1, 2, 3 and 6. Yes, 1 is also a factor and 6 is also a factor. But what is the remainder being talked about? The remainder of 2. We will count those many numbers which are not less than or equal to 2. That is, which are more than 2. How many of these numbers are more than 2? Only 2 of them. That is 3 and 6. So what will our answer be? Our answer would be 2, not 3. So there are 2 numbers which divide 140 and 176 and leave a remainder of 2 in each cases. So our statement 1 was true, our statement 2 happened to be false. So what will our answer be? Our answer will be option A, 1 only. Okay. Now this might seem a bit overwhelming, but as I told you earlier, watch the video once again and you will be able to understand the concept better, because on this concept there were 2 questions in the 2024 paper. We will discuss the other question and its concept in the next video. Okay. Now I think it is time to go for your homework question. This is your homework question. 421 and 427, when divided by the same number, leave the same remainder 1. How many numbers can be used as the divisor in order to get the same remainder 1? This is the same concept of this statement 2 and this question. Both of them, they are the same concept. This question is based on the same concept. Do solve this and leave your answers in the comment section. We will discuss the answer in the next classes video. Okay. Now it is time to answer the previous classes homework question. This was your previous classes homework question. It was a question on ages. Let's read the question. A father said to his son, N years back, I was as old as you are now. My present age is 4 times your age N years back. If the sum of the present ages of the father and the son is 130 years, what is the difference of their ages? And we learnt 2 concepts in the previous class to solve this question. One was timeline of ages and the other was simultaneous equations. We shall use those concepts here and get the answer. How many timelines are there? There are 2 timelines. One is present and the other is N years back. How do we express them? We will express them in a tabular form. This is present and this is N years back. We will write it as minus n. And whose ages are we discussing? A father and his son. This is father and this is son. Let's take the present age of father as F and present age of son as S. So N years back, father's age would have been F minus n, and N years back, son's age would have been S minus n. Okay. Now let's read the statements. N years back, I was as old as you are now. Who is saying this? The father is saying this. He says that N years back, he was as old as the son is now. So it means that F minus n, that is equal to S, right? Because the father says that N years back, he was as old as the son is now. Okay. Let's read the second sentence. My present age is 4 times your age N years back. The father's present age is 4 times the son's age N years back. The father's age is 4 times the son's age 4 years back. How will we express it? We will express it as F is equal to 4 times of S minus N, right? Yes. And we have another statement to see. The sum of the present ages of the father and the son is 130. So F plus S is 130. So we have 3 equations, 3 variables. However, do you see that we have F readily available in all of them? We will just modify this equation. We will make it as F is equal to n plus s. Then we can substitute n plus s in place of f in both the equations. Then we will have two equations with only two variables, n and s. Yes, we shall do that. This equation will become, in place of f we will write n plus s. So n plus s is equal to 4 into s minus n. So how will we solve it? This would be n plus s is equal to 4s minus 4n. We will take ss one side on n's one side. So n plus 4n would be 4s minus s. 5n is equal to 3s. Okay, we will leave it there. Now we shall solve this one. We will once again substitute n plus s in place of f. What will we get? N plus s is equal to 130. Okay, n plus 2s is equal to 130. Okay, now we shall remove all of them. We just need these two equations. N plus 2s is equal to 130 and 5n is equal to 3s. Okay. N plus 2s is equal to 130 and 5n is equal to 3s. Okay. Now we shall solve these two equations. Here we see that we can do this, right? N is equal to 130 minus 2s, and there we have 5n. There we have 5n, and here we can express n as n is equal to 130 minus 2s. So we can multiply this whole equation with 5 to get 5n. Yes, why will you do that? I will tell you why. We'll multiply this whole equation with 5. It would be 5n is equal to 13 into 5 is 65. So 130 into 5 would be 650 minus 10s. Okay. Now we have 5n is equal to 650 minus s here, and we have 5n is equal to 3s here. So we have LHS same. So we can equate the RHS, right? Yes. What will it be? 650 minus 10s, it would be 3s. So we'll send this 10s that side. 650 is equal to 3s plus 10s. So 650 is equal to 13s. 650 divided by 13, that would be s, right? 650 divided by 13, that would be s. So we know that 13 5s are 65. So we will get 50 is equal to s. Okay, we got 50 is equal to s. We know that the sum of the present ages of father and son is 130. If the son's age is 50 plus the father's age, it should be 130. So what will the father's age be? It would be 130 minus 50, that would be 80. So father's age is 80 and the son's age is 50. They are asking us for the difference of their ages. 80 and 50, the difference would be 30 years, right? So the answer is 30 years. Okay. Now, I hope that the class was useful to you. If you like this class, do watch our class videos regularly. We upload one episode or one class every evening. Also, share the YouTube link to this class with your friends through WhatsApp groups and Telegram groups. Thank you, and most of all, I wish you a very happy studying.